Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about aromatic compounds. So let us start learning of aromatic compound. So what is the criteria for aromaticity? There are four structural criteria must be satisfied for a compound to be aromatic. A molecule must be cyclic. To be aromatic, each p orbital must overlap with the p orbitals on adjacent atom. Now, a molecule must be completely conjugated. Aromatic compound must have p orbital on every atom. You can see benzene a p orbital on every carbon aromatic. But in case of 1,3-cyclohexadiene, not aromatic. 1,3,5-cycloheptatriene, not aromatic. So these rings are not completely conjugated, no p orbitals. Now, a molecules must be planar. All adjacent p orbital must be aligned so that the pi electrons density can be delocalized. Cyclooctatetraene, not aromatic. A tub-shaped 8-member ring. Adjacent p orbital cannot overlap. Electrons cannot delocalized. So cyclic compounds, benzene, is aromatic. A molecule must satisfy Haeckel's rule and contains a particular number of pi electrons. An aromatic compound must contain 4n plus 2 pi electrons. Cyclic, planar, and completely conjugated compound that contains 4n pi electrons are especially unstable and are said to be antiaromatic. Benzene is aromatic and especially stable because it contains 6 pi electrons. Cyclobutadiene is antiaromatic and especially unstable because it contains 4 pi electrons. Now, considering aromaticity, a compound can be classified into one of the three ways: aromatic, a cyclic, planar, completely conjugated compound with the 4n plus 2 pi electrons; antiaromatic, cyclic, planar, completely conjugated compound with 4n pi electrons; no aromatic, non-aromatic, a compound that lacks one or more of the following requirement for aromaticity, being cyclic, planar, and completely conjugated. Now note the relationship between each compound type and a similar open chain molecules having the same number of pi. An aromatic compound is more stable than similar a cyclic compound having the same number of pi electrons. Benzene is more stable than 135 etc. An anti-aromatic compound is less stable than a cyclic compound having the same number of pi electrons. Cyclobutadiene is less stable than 1,3-butadiene. A compound that is not aromatic is similar in stability to an electron. A cyclic compound having the same number of pi electrons, 1,3-cyclohexadiene, is similar in stability to 6,6,2,4-hexadiene, so it is aromatic. Look at here, benzene, more stable, 1,3,5-hexatriene. Here cyclobutadiene, 1,3-butadiene, less stable, anti-aromatic. Here non-aromatic 1,3-cyclohexadiene, 6,6,2,4-hexadiene, similar stability. So aromatic heterocyclic compound. Heteroatoms donate 1 electrons. Heteroatoms donate 2 electrons. You can see the pyridine, pyrrole, furan, and thiophene. A heterocyclic compound has ring atom other than carbon. Heteroatoms donate either 1 or 2 electrons to the pi system. So pyridine, a 6-member heterocycles with a nitrogen atom in its ring. Pi electron structure resembles benzene, 6 electrons. The nitrogen lone pair electrons are not part of the aromatic system, perpendicular orbital. So 2 pi electrons, 2 pi electrons, 2 pi electrons, and these electrons are not involved in the pi system. Now pyrrole, a 5-member heterocycle with 1 nitrogen. Pi electron system similar to that of cyclopentadienyl anion. Nitrogen atom in sp2 hybridized, a lone pair of electrons occupies a p orbital, 6 pi electrons. So you can see the pyrroles, 2 pi electrons, 2 pi electrons, 2 pi electrons. So furan structure. You can see these electrons are not involved in the pi system, and 2 pi electron, 2 pi electron, pi electron. Furan and thiophene structure are similar. Now, inulin. Hydrocarbons containing single ring with alternating double and single bonds are called inulins. Completely conjugated rings larger than benzene are also aromatic if they are planar and having 4n plus 2 pi electrons. To name an inulins, indicate the number of atoms in the ring in bracket and the word inulins. Look at 14 inulins and 18 inulins. So 10 inulins has 10 pi electrons which satisfied Haeckel's rule, but planar molecules would place the two hydrogen inside the ring too close to each other. Thus the ring pucker to relieve this strain. Since 10 aluline is not planar, the 10 pi electrons cannot delocalize over the entire ring and it is not aromatic. So thank you. If you like this video, then subscribe my channel and thanks for watching.